Alright, today we're going to have a look at topic 9, quadratic equations, part 1. Okay, first of all, let's have a look at the introduction of quadratic equation. So any equation with this form, ax squared plus bx plus c equals 0, where a, b, and c are coefficients, and x is an independent variable. So any equation with this form is called a quadratic equation. Of course, here a is not 0, otherwise it's a linear equation, not a quadratic one. So these equations are called quadratic equations, where ax squared term is called the quadratic term. Bx term is a linear term, and c term is a constant term. The expression ax squared plus bx plus c is a quadratic expression, and a, b, and c are coefficients of the expression. It will often refer to a quadratic equation or expression simply as a quadratic. We also sometimes call a quadratic in which x is a variable a quadratic in x. Similarly, y squared plus 3y plus 2 is a quadratic in y, and 3r squared plus 2r minus 5 is another quadratic in r. So previously we have solved linear equations by isolating the variable, right? Unfortunately, having both an x squared and x term makes isolating the variable in a quadratic equation a little trickier. So we'll start our exploration of quadratics by considering quadratics that do not have a linear term. So let's use an example to illustrate the concept here. So consider two questions. First, can you find the values of x that satisfy the equation x squared equals 16? Then can you find the values of x that satisfy the equation 2x squared minus 576 equals 0. So note that in both of the quadratic equations, we do not have a linear term, bx, right? So when you finish, please give me your answer in the chat box, okay? Alright, have you finished both of them? Okay, let's have a look at the solution. So in question A, we can isolate x by taking the square root of both sides to get x equals positive 4, right? However, we must remember that since negative 4 squared is also 16, the value x equals negative 4 will also satisfy the equation x squared equals 16, right? Therefore, both x equals 4 and negative 4 are solutions to the equation. So the solution is x is either positive or negative 4. Do not forget the negative 4, okay? And for the second equation, first we can isolate x squared. So basically we have 2x squared equals 576, and then x squared equals 288. And of course x is either positive or negative square root of 288. And simplify this will give us x is either positive or negative 12 square root 2. Any questions? So this tells us that isolating the variable works just fine when there's no linear term. But we have to remember the plus minus issue. Why won't isolating x squared work when there's a linear term? Because, well, let's try. If you have a quadratic equation like this, if we just isolate x squared, we will get x squared equals 5x minus 6, right? So taking the square root will give us positive or negative square root of 5x minus 6. So we'll stop there, right? So let's go back to the question and look at a quadratic without a constant term for more guidance. Okay, so next let's consider the second case where there is no constant term in the quadratic equation. So can you find the solutions to this equation? X squared minus 6x equals 0. And again, when you finish, please give me your answer in chat box, okay? Alright, have you finished? Okay, let's have a look at the solution here. So the original equation is equivalent to this one. We can factorize x outside the parentheses, right? So that means x times x minus 6 equals 0. So basically you have a product of two numbers, x and x minus 6 equals 0. Therefore we have either x equals 0 or x minus 6 is 0, right? Therefore our final solution is x is 0, or x can also be 6. You get it? So as you can see here, if there is no linear term or there is no constant term, it's very easy to solve a quadratic equation, right? And in order to solve the quadratic equation in a more general sense, for example, both a and b are not 0 and c is not 0, we need to use some techniques to factorize the quadratic expression. So next, let's have a look at common techniques we can use to factor quadratic expression to help us solve the quadratic equation. So the first method we can use is called factoring out the greatest common factor, or GCF. It's very intuitive, right? So let's have a look at this example here. Suppose you have a expression like this, then we know 3x minus 1 is the common factor of these two terms, right? So that equals, well, if we put 3x minus 1 in front, then what's left in the parentheses is just the x plus 5, right? So this is the method called factoring out the greatest common factor. So when you are facing a quadratic expression, always think about whether you can factor out the greatest common factor first. Any questions? Alright, if you don't have any question, let's do some exercise here. Can you factor each of the following expressions? First, x squared minus 7x. Second, 3x times x plus 7 minus 2 times x plus 7. And can you solve the following equation? Again, when you finish, please give me an answer in chat box, okay? Alright, let's have a look at the solution together. First of all, we can factorize the common factor s, right? So this equals s times s minus 7. Okay, second question, the common factor is x plus 7, so we can put it in front, x plus 7 times, we have a 3x minus 2, right? So we can use this method to solve the following equation. So first of all, the original equation is equivalent to, so by equivalent I mean after you transform the equation, you don't change the solution set. So first of all, we can put the common factor 2x plus 3 in front. Then we have a x plus 15 equals 0. Therefore, you have a product of two numbers equals 0, which means either we have 2x plus 3 is 0 or x plus 15 is 0, right? Therefore, the final solution is x is either negative 3 over 2 or x equals negative 15. Any questions? Okay, if you don't have any questions, let's have a look at the second method we can use to factor quadratic expressions. In the second method, we can use some special expressions or formulas. So here are some commonly used formulas for factoring quadratics. First, if you have a squared minus b squared, this equals a plus b times a minus b, right? Because when you expand the right side, you will get a squared plus ba minus ab minus b squared, which gives you a squared minus b squared, which is exactly the left side, right? So when you have a squared minus b squared, you can always factorize to a plus b times a minus b. And secondly, when you have a squared plus 2ab plus b squared, this can be written as a plus b squared. Again, because when you expand the right side, it's basically a plus b times a plus b. This will give us a squared plus ab plus another ab plus b squared, which is exactly the left side, right? So when you have a expression a squared plus 2ab plus b squared, you can rewrite that in a factorized form, a plus b squared. And similarly, when you have a squared minus 2ab, we can factorize that to a minus b squared. For example, if we have expression like this, 4x squared minus 16, so note that this can be written as 2x squared minus 4 squared, right? So we can factorize to 2x plus 4 times 2x minus 4, right? Of course, this can be simplified to 2 times x plus 2 times 2 times x minus 2. Yeah, this gives us 4 times x plus 2 times x minus 2, right? And of course, usually, like I said, in the first step, you can also apply factoring out the GCF. So usually in the first step, always try to factor out the greatest common factor, which is 4 in that case, right? So you can also do it like this. So first of all, factorize the 4 out. So this will give us 4 times x squared minus 4, right? X squared minus 4 is actually x squared minus 2 squared, and this gives us 4 times x plus 2 times x minus 2, right? You can use either way. Okay, so these are the commonly used formulas we can use to factorize quadratic expression, and I'll give you some more. So if you have an expression that is not a quadratic expression, but a cubed plus or minus b cubed, we can also factor that to a plus b or minus b times a squared minus or plus ab plus b squared. This is also a very important formula you can use when you have an expression like this. So why is that? Because, well, let's try to verify this one. A plus b times a squared minus ab plus b squared. Again, when you expand it, you will get a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed, right? Therefore, we can actually cancel these terms in the middle. So this will give us a squared plus b squared, right? Again, when you verify the other one, a minus b times a squared plus ab plus b squared, you will get similar result. This will give us a cubed plus a squared b plus ab squared minus a squared b minus ab squared minus b cubed. Again, we can cancel all the terms in the middle. So this will give us a cubed minus b cubed. You get it? So here you should memorize this one, this one, this one, and that one. You have these commonly used formulas to factorize expression like this. Any questions? So I'll give you some time to write this down on your notebook. Okay, any questions, just let me know. Alright, if you don't have any questions, let's do some exercise. Can you factorize each of the following expressions and solve each of the following equations? And again, when you finish, please give me an answer in chat box, okay? And then let's have a look at each of the following equations. First of all, well, there is no common factor, right? But note that the first term is just 3x squared, and the third term is 8 squared. And in the middle, we have 2 times the first term, 3x, times the third term, 8, which is exactly 48x. So this can be written as, well, this original equation is equivalent to 3x plus 8 squared equals 0, right? After the transformation, we didn't change its solution set, so we can just try to solve the new equation here. And this is equivalent to, well, if you have something squared equals 0, apparently 3x plus 8 must be 0, right? And therefore the solution is x equals negative 8 over 3. Okay, next one, we know that the first term is 2y squared, and the third term is 9 squared. And right in the middle, we have 2 times 2y times 9, which is 36y. But we have negative 36y here, right? Therefore, the original equation is equivalent to 2y minus 9 squared equals 0. And of course, if you have something squared equals 0, we have 2y minus 9 must be 0, right? Therefore, the solution is y equals positive 9 over 2. Okay, last one, we have first term is x squared, last term is 1 over 2 squared. And 2ab gives us x exactly in the middle, right? So we can rewrite this equation to x plus 1 over 2 squared equals 0, which gives us x plus 1/2 must equal 0. Therefore, solution is x equals negative 1 over 2, right? Okay, have a look at the question here. Any questions you want to ask? Okay, if you don't have any question, let's have a look at the third method we can use, which is called trial and error, or cross multiplication, or cross product. So let's use an example to illustrate the method here. So if you have an expression x squared plus 5x plus 6, apparently this is a quadratic expression, right? And we have 3 terms, so this is called a trinomial, and usually we can use a cross product to help us factor that. So first of all, if you have x squared here, x squared can be factorized to x by x, right? So we can put x by x in the first row here. And then we consider the 6. We try to factor 6. 6 can be factored to either 1 by 6, or negative 1 by negative 6, or negative 2 by negative 3, or 2 by 3, right? So why this method is called trial and error? Because we're trying to factorize 6 in different ways to see in which way we can get 5x in the middle. So first of all, we have 1 by 6, right? In that way, we have 6x plus 1x, which equals 7x. This is not the case in the middle. We don't have 7x, but 5x here, right? So now let's try the next one, negative 1, negative 6. Of course, this will give us negative 6x minus x, which is negative 7x. Still, this doesn't work because we have 5x in the middle, right? And then we can factorize 6 to negative 2 by negative 3. This will give us negative 3 minus 2x, which is negative 5x, which is not positive 5x there, right? And of course, we can also factorize 6 to 2 by 3. In this way, the cross product will give us 3x plus 2x, which is exactly 5x in the middle, right? Therefore, we have to accept the last case here. So this is your first factor. This is a second factor. So we know the original trinomial can be factorized to x plus 2 multiplied by x plus 3. Of course, if you're not so sure about it, you can always verify this by expanding the factorized form back to the expanded form. So if you expand it, you will get x squared plus 2x plus 3x, which is 5x, then plus 6, which is exactly the same as the original expression, right? Remember, you can always verify that by expanding it back. Are you clear with this method?
Yeah.
Okay, then next let's have a look at some exercise. Can you factor each of the following expressions? And when you finish, please give me your answer in the chat box, okay? Alright, have you finished? So let's have a look at the solution here. Well, the first one, x squared can be factorized to x by x, right? Then we need to factor 15 in order to get 8x here. Apparently 15 can be factored to 3 by 5. In that way, we have 3x plus 5x, which gives us 8x in the middle, right? Therefore, we know the original expression equals x plus 3 times x plus 5, right? For the second one, again, x squared can be factorized to x by x, and negative 24 can be factorized to negative 8 by positive 3, because we want negative 5x in the middle. So we have, in this way, the cross product that will give us 3x minus 8x, which is exactly negative x in the middle, right? So this equals x minus 8 times x plus 3. Not x plus 3 times x, not x plus 8 times x minus 3, but x minus 8 times x plus 3. Okay, careful with that. The next one, r squared can be factorized to r by r. 28 can be factorized to, well, we have 4 by 7, right? But we want negative 11 here, so we need to factorize 28 to negative 4 by negative 7. In that way, we have negative 4r minus 7r, which equals negative 11r. And this equals r minus 4 times r minus 7. Okay, next one, x squared plus 10x plus 25. And we can directly use a formula, right? Because x 5 times 2 is 10x. So you can just directly write x plus 5 squared. Okay, next one. First of all, if you're not familiar with this, you can always rearrange the terms in the descending order. So this gives us negative x squared minus x plus 56, right? So first of all, negative x squared can be factorized to x by negative x. And 56 can be factorized to 7 by 8. In order to have negative x here, we need to put 8 here and a 7 here. In this way, we have negative 8x plus positive 7x. And of course, this gives us negative x in the middle, right? So that equals x plus 8 times negative x plus 7. Any questions? Okay, if you don't have any questions, let's consider some other cases. Can you solve each of the following equations using what we have learned so far? Alright, have you finished? Okay, first one, 2x squared can be factorized to x by 2x, right? And we need to factor negative 35 in order to have a cross product of negative 3 in the middle. So we can try using 5 here and put a 7 here. And note that this will give us the difference is 3x, right? And we need to put a negative symbol here because in this way we will have negative 10x plus 7x, which gives us negative 3x in the middle, right? So the original equation is equivalent to x minus 5 times 2x plus 7 equals 0. Therefore, we know the solutions are x is either 5 or x is either negative 7 over 2, right? For the second one, 2x squared can be factorized to x by 2x. Negative 45 can be factorized to 5 by 9, but in that case, we should put a 5 here, 9 here, because we need the difference to be x, right? And we need to put a negative symbol here. This way we'll have 10x minus 9x, which gives us x in the middle. And therefore, this is equivalent to x plus 5, then 2x minus 9 equals 0. And therefore, we know x is either negative 5 or x equals 9 over 2, right? Okay, the third one seems a little tricky. Okay, first of all, there is no GCF for 12, 8, and 15, right? So probably you'll need to do a lot of trial and error test because there are a lot of combinations for 12 and negative 15. But remember, you need negative 8 in the middle, right? So first of all, we can try using, how about 3x by 4x? This will give us 12x squared for the first term. Then we can, well, let's just try to 3 by 5. Then we have 15, 12, doesn't work. So how about we put 5 here and 3 here. And this is 20 minus 9, still doesn't work, right? So probably we'll factorize 12x squared to 2x by 6x. Then try 15 is factorized to 3 by 5 here. And then bingo, we have found a correct combination because we have 18 minus 10, which is negative 8, which is positive 8 here, right? But we need negative 8, therefore you need to put a negative symbol here. So negative 3 by 5 will give you negative 15 here. And the cross product will give us negative 18x plus 10x, which is negative 8x, which is exactly the term in the middle. Therefore, this equation is equivalent to 2x minus 3 times 6x plus 5, right? If you are not so sure, always try to verify that by expanding it back. So if you expand it, you will get 12x squared plus 10x minus 18x minus 15. Of course, this is the same with the original equation, right? So our factorization is correct here. Therefore, we know the solution is x is either 3 over 2 or x can also be negative 5 over 6. These are the solutions. Okay, last one, 8x. Well, let's try 2x by 4x. Then we have 23 in the middle, so we could probably do a 5 by 3. That's too much, right? So it doesn't work. So how about 3 by 5 here? Okay, too little. So probably not a good idea to factorize the first one to 2 by 4. So how about x by 8x? And try to put a 15 here and 1 here. Then work done, right? So the cross product will give us 8x plus 15x, which is 23x, which is a term in the middle. Therefore, the original equation is equivalent to x plus 1 times 8x plus 15 equals 0. Therefore, the solution is x either -1 or x can also be -15 over 8, right? Do you have any questions? Okay, if you don't have any question, let's see the fourth method we can use to factorize a quadratic expression, which is called completing the square. For example, if you have an expression like this is another quadratic expression, right? We can rewrite this to, well, if you only consider the first two terms, what does it remind you? Well, if you put a 4 here, then x squared plus 4x plus 4 will give us x plus 2 squared, right? So we can rewrite this to x squared plus 4x, well, plus another 4, right? Well, if you add an extra 4, remember to compensate that by adding a -4 as well, in order for the new expression to be exactly the same with the original one. And then we can use a formula to help us to factorize the first three terms, which is x plus 2 squared, right? And -4 plus 1 will give us -3, right? And this is actually x plus 2 squared minus 3 square root 3 squared, right? Therefore, we can further factorize that to x plus 2 plus square root 3, then x plus 2 minus square root 3. Did you get it? So this is called completing the square method. You have any questions? Okay, good. If you don't have any questions, let's see some exercise. Can you solve each of the following equations? Alright, have you finished? So for the first question, in order to complete the square, we need to add a positive 1, right? So the first equation is equivalent to x squared minus 2x plus 1. But if you add plus 1, remember to compensate that by adding a negative 1. Then copy the rest of that equation here. So the new equation does not change the solution set. It's basically exactly the same with the original equation because these two terms can cancel with each other, right? But in this case, we have, well, if you only consider the first three terms, we have x minus 1 squared, right? Then minus 1 minus another 1, this is minus 2 equals 0. And then the left side of the equation can be further factorized to x minus 1 plus square root 2, then x minus 1 minus square root 2 equals 0, right? And therefore we know there are two solutions, x equals 1 minus square root 2, or x can also be 1 plus square root 2, right? So how about the second one? So in order to complete the square, we can add a plus 1 over 2, right? Then remember to compensate that by add a negative 1 over 2. And copy the rest of this equation. And then the first three terms gives us x minus 1 over 2. Oh, sorry. We should add a quarter, not a half. So the first three terms gives us x minus 1 over 2 squared, right? Because if you expand it, you will get x squared minus x plus 1 quarter. And then minus 1 quarter plus 3 over 16. This is actually negative 4 over 16 plus 3 over 16, which is negative 1 over 16, right? And then we know this can be further factorized to x minus 1 over 2 plus 1 over 4 times x minus 1 over 2 minus 1 over 4 equals 0, which is equivalent to x minus 1 over 4 times x minus 3 over 4 equals 0, right? And of course the solutions are x is 1 over 4 or x equals 3 over 4. Okay, the last one. So here we have 3x squared, and in order to complete the square, note that in the middle we have 2 times 3x times another number, right? So the other number is, of course, 2, right? So we can put 2 squared there, 9x squared by 12x plus a 4 minus a 4 plus 15 over 4 equals 0. First three terms give us 3x minus 2 squared, right? Because if you expand it, you will get 9x squared minus 12x plus 4. Then minus 4 plus 15 over 4 is actually negative 16 over 4 plus 15 over 4. This will give us negative 1 over 4, right? Equals 0. And this can be further factorized to 3x minus 2 plus 1 over 2 times 3x minus 2 minus 1 over 2 equals 0, which is equivalent to 3x minus 3 over 2 times 3x minus 5 over 2, right? Equals 0. Therefore, we have x is either, or 3x is 3 over 2. So x is 1 over 2. x is either 1 over 2 or x is 5 over 6, right? Any questions? Okay, if no questions, let's have a look at the next method we can use is called substitution, which is usually used to solve a quadratic equation or factorize quadratic expression in disguise. For example, if we want to factorize the following expression, we could let x squared equals u, then we know, let's call this star. So the original expression equals 15u squared plus 38u plus 7, right? And this is actually a quadratic expression which we have already know how to factor. So we can use trial and error method, right? 15u can be factorized to 3u by 5u. In order to have 38u there, we need to factorize 7 to 7 by 1. This will give us 35u plus 3u, which is 38u in the middle. And therefore that equals 3u plus 7 times 5u plus 1, right? And of course it's not finished yet because the original expression is in terms of x. So we need to substitute u using x squared. So that equals 3x squared plus 7, then 5, u is x squared, right? So 5x squared plus 1. Did you get it? Any questions? Okay, if you don't have any questions, now it's your turn to complete these two exercises. Can you solve each of the following questions? Okay, have you finished? Alright, so for the first question, we haven't learned how to solve a expression which has a power 4, right? So you can always let x to the power 4 equals, you can always let x squared equals u. In this way, we can lower the power number to 2, right? So in that case, the original expression is equivalent to 4u squared minus 9 equals 0, which is equivalent to 4u squared equals 9, and u squared equals 9 over 4, right? So note that u equals x squared. Of course, u is greater than or equal to 0, because in by default, we currently we only solve equations in the real number set. If x is a real number, x squared must be non-negative, right? Therefore, we know there is only one solution. U must be greater than or equal to 0. So u must equal positive 3 over 2. U cannot be negative number, right? And if u equals 3 over 2, that means x squared equals 3 over 2. But x can be any real number, so x can be either positive or negative square root 3 over 2, which equals negative or positive or negative square root 6 over 2, right? So how about the second one? Again, you could let x squared be u, then the original equation is equivalent to 6u squared minus u minus 2 equals 0. And apparently this is a quadratic equation, right? And we can factorize that to 2u by 3u and put a 2 here, 1 here. In order to have a negative u in the middle, we need to put a negative symbol here. In this way, we have 3u minus 4u, which gives us negative u. Therefore, this is equivalent to 2u plus 1, and then 3u minus 2 equals 0, right? Therefore, we have u is either negative 1 over 2 or u is 2 over 3. But be careful, again, x is a real number squared equals u, so u must be greater than or equal to 0. So this is not possible, so we need to discard this solution. U cannot be a negative number. Therefore, u can only be 2 over 3. Therefore, we know x squared equals 2 over 3. So x equals either positive or negative square root of 2 over 3, which is either positive or negative square root 6 over 3, right? Do you have any questions? Okay, so basically we have learned 5 methods to help us factor a quadratic expression, and you can use this method to help us to solve a quadratic equation. Also note that if a quadratic cannot be factored, well, in real number set, it is called a prime quadratic in real number set. For example, in the real number set, we cannot factorize this expression here. Therefore, this quadratic expression is called prime quadratic in real number set. Any questions? Okay, if no questions, let's have a look at some trivial concept related to rationalizing denominators. When we solve quadratic equation, sometimes we need to rationalize the denominator. So let's have a look at some common method we can use. So first example, rationalize the denominator. 4 over square root 6. So note that there is only one term in these two examples, right? So first one is pretty easy, 4 over square root 6. In order to rationalize the denominator, we need to multiply both the numerator and denominator using square root 6, right? So in this way, we get 4 square root 6 over 6, and this can be simplified to 2 square root 6 over 3. Next one, we have cubic root of 2 over 3a. So in order to rationalize the denominator, we need to multiply a cubic root of 9a squared. to both numerator and denominator, right? So here the denominator becomes cubic root of 27a cubed. Numerator becomes cubic root of 18a squared. And then the denominator becomes 3a, right? And the numerator is just cubic root of 18a squared. Cannot simplify that further. And sometimes we have two terms in the denominator position. So let's consider these two examples here. The first one, if you want to rationalize the denominator, we need to multiply both the numerator and denominator using x minus square root 3, right? And this will give us 4 times x minus square root 3 over, remember we can use the formula here, right? A plus b times a minus b gives us a squared minus b squared, which is 3 here. And therefore the denominator is rationalized. Okay, how about the next one? So this one, in order to rationalize the denominator, we need to multiply both the numerator and denominator using square root 5 plus square root 6, right? And this will give us, well, we can expand the numerator to square root 2 times square root 5 plus square root 2 times square root 6 plus square root 3 times square root 5 plus square root 3 times square root 6. And the denominator becomes just, again, we can use the formula to expand that, which is 5 minus 6, right? So this will give us square root 10 plus square root 12 plus square root 15 plus square root 18 over -1, right? And this can be further simplified to negative square root 10 plus 2 square root 3 plus 15 plus 3 square root 2. Did you get it? So if you don't have any questions, I'll give you some exercise for you to solve, okay? Can you rationalize denominator for each of the following expressions? And there are more of them. So you can copy them first, and I'll give you some time to solve them. After that, we'll have a look at the solution together. Alright, have you finished? The first one is pretty easy, right? Which equals 7 square root 11 over 11, right? And the second one, we have a cubic root of 5y over cubic root of 2. Therefore, we need to multiply both the numerator and denominator using cubic root of 4. So we have cubic root of 20y over cubic root of 8, which is 2, right? Okay, next one, multiply both numerator and denominator using square root a minus square root b. So this will give us a minus b equals a minus square root ab over a minus b. Okay, next one, multiply both numerator and denominator using square root 7 plus square root 6. And this gives us 7 minus 6, right? So equals square root 7 plus square root 6. Okay, how about this one? We have 3 terms in the denominator. So first, we can multiply both the numerator and denominator using this number. According to the formula, this will give us square root 2 plus square root 3 squared minus second number squared, which is 5, right? And if you expand it, this is actually 2 plus 3, then plus 2 times square root 6, right? Then minus 5. We'll cancel this number here. So that's just 2 square root 6. And then we can multiply both the numerator and denominator using square root 6. Then the denominator becomes 12, right? So we have square root 12 plus square root 18 minus square root 30 over 12. And of course we can simplify that further. Square root 12 is 2 square root 3. Square root 18 is 3 square root 2. Then minus square root 30 over 12, right? And then denominator is rationalized. How about the last one? So remember, we have learned a formula called a minus b times a squared plus ab plus b squared. This can be written as a cubed minus b cubed, right? So apparently we have this number is a, this number is b. So how about we multiply both numerator and denominator using this term here, which is 2 squared plus 2 times cubic root of 2 plus cubic root of 2 then squared. Then the denominator becomes the first number cube, which is 8, minus the second number cube, which is 2, right? And then as you can see here, the denominator is rationalized. So we have 4 plus 2 times cubic root of 2 plus, well, cubic root of 2 then squared is actually cubic root of 2 squared, which is cubic root of 4, right? Over 6. Okay, so this is pretty much about it. And first part of quadratic equations, we have learned the concept of quadratic expression and quadratic equation, and we have already also learned 5 different methods to factor a given quadratic expression to help us to solve quadratic equations. And next, we have discussed a common method to rationalize denominators. So after this class, I'll give you my notes together with the lecture video and some homework. Remember to complete the homework before the deadline and submit that to my email address, okay? And if you don't have any questions, class dismissed. I'll see you next time. Bye.